So hopefully by now you're familiar with both series and parallel circuits. So in this video we're going to look at a circuit that has elements of both a series circuit and a parallel circuit. So we have two resistors in series here, and then we have two parallel branches here and here. Now, the resistance of our first resistor are 6 ohms. The resistance in our second resistor are 4 ohms. In our first parallel branch, R3, we have resistance of 8 ohms. And in our last resistor, R4, we have resistance of 16 ohms. And the voltage of our power source is going to be 56 volts. So, what we're going to do is find the equivalent resistance for our entire circuit. But before we can do that, we have to find the equivalent resistance in our two parallel branches. So, 1 over the equivalent resistance equals 1 over 8 plus 1 over 16, which when you solve with your calculator is 5.33 ohms. So now we know that the equivalent resistance in the two parallel branches is 5.33 ohms, and now we can just add our 6 ohms and our 4 ohms to get a total 15.33 ohms. So now we'll take the voltage of our power source, 56 volts, divide by 15.33 ohms, and that gives us 3.65 amps. Now that's going to do the current in each of the circuits. In our series circuit part, in R1 and R2, and it's also going to be the total current between the two resistors R3 and R4, which we'll find later when we solve. So now we're going to find the voltage drops beginning in resistors R1 and R2. So we have 3.65 amps of current times 6 ohms of resistance in R1, which gives us 21.9 volts of voltage drop in resistor R1. In resistor R2, we have 3.65 amps times 4 ohms, which equals 14.6 volts. And if we add those together, we find that a total of 36.5 volts drops through the first resistor. So now we have to find how many volts will be dropping through resistors R3 and R4, our two parallel branches, and we can simply do that by subtracting the 36.5 from 56, our total voltage, which is 19.5 volts. And from parallel circuits, you know that this 19.5 volts is going to drop through both resistors R3 and R4, but the main difference that we're going to see is that the current in resistors R3 and R4 will be different because of their varying resistances. So, in resistor R3, we know that 19.5 volts drop, and that we have resistance of 8 ohms is going to be 2.44 amps, and 19.5 volts divided by 16 ohms, as you may expect, will yield exactly half as much current, 1.22 amps. And then when we add 2.44 and 1.22, we find that the total current through resistors R3 and R4 is 3.66 amps, which as we found earlier, is essentially the same as the current resistor R1 and R2. So we can go back and label our circuit finally with all the voltage drops. So here we have a 21.9, here we have 14.6, and then both of these 19.5, and a current of 2.44 amps, and a current of 1.22 amps. I hope that's helpful.